Yeah, back with a Codewars exercise called Square Digits Sequence. Doing this one in Python, y'all. Look at the description. It says, consider a sequence of numbers, if you will. Consider a sequence of numbers in which an element is equal to the sum of square digits of the previous element. The sequence ends once an element that has already been in the sequence appears again. Given the first element a0, find the length of the sequence. So we're going to be given a number, you separate the digits, you square each digit, add them together, producing another number, and you do that process over and over again until you end up with the same number. So let's look at an example here. This one will get a little thick here. So if we begin with a 16, the outcome will be 9. And what you're supposed to do is find the length of the sequence. So eventually it's going to come back around and 16 is going to be in the sequence again. You have to find out how many numbers are going to be in the sequence until 16 comes up again. So find the length of the sequence. Let's take a look. In this example, you start with 16, then you separate the digits. 1 squared, 6 squared, add them together, 37. Then you separate the 37th digits, square them, 58. So what you're going to do is, for every turn, you're going to separate the digits, square each digit, add them together once they are squared. And then you just kind of, you keep hopping along, and then you get here with the 4. 4 squared is 16, so the 16 comes back around again. 16 is 16. The job is going to be how many elements are going to be in the sequence once the original number comes back around again. Let's just count. 1, 2, 3, 4, 5, 6. Like all the clicking? 7, 8. And then the last one is 9. So it is inclusive of the last and the first. So yeah, 9 elements in the sequence, if you see it down here. 9. So that's what we got to do. We're going to get a number. We're going to separate the digits, square each digit, add them together, and then do it again and again and again until we get the original number. All right, so I'm going to do this one in PyCharm because I want to demonstrate this example so you can see the breakdown. I think it'll be instructive. But let's go ahead and slide this over here and get started. As I begin, I'm going to create a list to store the results of every square and sum operation. That's what I'm going to do. And then this is going to be more of a temporary list where I'm going to, well, you'll see what I do, but I'm going to use this to, for each number, I'm going to use this to separate the digits, and then I'm going to, the digits of that number, then I'm going to use it to help me do the squaring of the digit and the summation. So current digits will be involved in the number by number operation of doing the separate the digits, square, sum. Used digits will be all the outcomes. And then I'm going to create a variable here, and then I'm going to do a loop. And here what I'm doing is I'm I'm going to do a loop really according to when I need to stop. And when I need to stop is going to be once the original number comes back around again. And that's what it's going to be. So that's what I'm going to do. And I'm going to first place my original, whoops, in there. And no, I don't need that. Because of course the used digits is going to be all of the numbers that, it's going to be all the numbers that are outcomes. And then I'm going to get the number of the outcomes once that original number comes back around again, so that I can solve the problem, because the problem is going to be how many numbers in a sequence are going to be used so that the original number comes back around again. Whoops. And it's greater than 0. This is going to be the breakup of the current number into its digits. Yeah, for those who don't know, this is really the algorithm to take one digit at a time and put it into a list. Where line 10, I'm doing modulo to get the number in the ones place and put it into a list. And then on line 11, I am using division to remove the ones place so that I can get the next number. So it's removing one number at a time from a multi-digit number, so that I can have them separated, so that I can then square them and add them together. And once they are separated, I'm going to loop through the digits. And I'm going to get the sum of the squares of each digit. So we're going to square each digit, get the sum in kernum. That's what kernum is being used for, getting the squares. And then current digits is really a temporary list, so I'm going to clear it because its job is done. Its job is just to hold the individual digits of the number. And once I've got my sum of the squares, I can clear it out for the next turn of the loop, or the next iteration of the loop, where I can fill it up again. And then what I do here after that is I'm going to make n my current, I want to make n my new sum of the squares, because on the next iteration I'm going to use that one to separate and get the sum of the squares. So it's just now n is the next result, and it's going to keep being the next result and the next result. And then I'm going to see, of course, once n comes up again, it'll be the end of the solution. And I'll set kernum equal to 0 to clear that out, because I'm going to reuse it. See, that was the sum of my squares. I'm going to reuse it when the loop turns back around. Yeah. And once the main while loop is over, I want to add the last result that I got to the end to make the list complete, because this loop, as it's constructed, will not add my final result. Meaning, like for the example from Codewars, when that 16 comes back around again, on the last turn it's not added, so I go ahead and add it here, because the adding is done at the top, and on the final turn, I'm going to hit this condition and then it's going to leave. So I'm doing this one-off add to the end so that I can add my 16 in that specific case back to the end. And then once that one is added, I'm going to return the length so that I can, that's the solution, because you want to see how long the sequence is, and I'm going to return the length of that sequence. All right, so now I'm going to run this thing with 16, and I'm going to first, ensure it's the right answer, and then I'm going to actually, and I'm going to modify this a bit because I wanted to show you the actual sequence that is generated. So I'm going to use a print statement in here to show you. There's your sequence. I guess I'll use an F string on this one as well to give it a label. Okay. Gonna do a little split screen here so I can show the example along with my call here. All right, gonna run it. Okay, looking down here, look at the sequence generated, 16, 37, 58, blah, 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 blah. But notice the 16 comes back around again. And 16, let's say 1 squared plus 6 squared is 37, then 3 squared plus 7 squared is 58, and so on. And you look over here in this sequence, all the outcomes are the same, you see? And then of course you have the 16 that comes up again. So there you go. This one's ready to run because I've only done one case, but of course I've submitted the solution before, so I know it's good. And this is the kicker. The result of the function call is 9. There are 9 numbers in the sequence, so there we go. All right, enough yammering. Let's get this thing on and delete the print. Don't need that. Get my function body on a Codewars, my friends. Let's get into this training interface and submit this and kill it. Mark it. Oh yeah, I can't submit here like that. All right. Test it. That one looks good. Great, stupendous, fantabulous. We got it. So there, my friends, is, I think the name of this is square digit sequence. Let's see. Yeah. So that is squared digits sequence from Codewars. My name is Dean. I'm good and you're good. And with that one, I am out.